Let's start today's Leetcode question. Reverse linked list. So reversing linked list is quite a common question. But what is two? So given a head of a singly linked list and two integers left and right, where left is less than or equal to right, reverse the nodes of the list from left to position right. Return the reversed linked list. Oh, okay. It's a different question, interesting question. Let me write down a few things. Let's see. I have input of head, and what is the left and right? Is it a node or just a position? Okay, so it's a position in T. So node head and then integer left and right. These are the three inputs, and what they want is node head but the reversed list at left right. That's the requirement. Reverse the nodes of the list from position left to position right. Okay, so let's try to find out some edge cases. So based on size, so can this list be an empty list? So that's the first question. So it cannot be empty, so at least there will be one node. Okay, and maximum there are 500 nodes. That's good to know. And the left and right will be in this in this area, and left can be equal to right, so it can be a same node. So in that case, if it is equal, then I don't think this case is like base case. If it is equal, then just return the head as it is. I think so. Yeah, and then the values. So I don't think we are working with the values here that much, so it doesn't matter per se, but the values can be anything. So yeah, so not to worry about it. That's fine. Cool. And going through my checklist of edge and test cases which I discussed above. Then there is algorithm design, there is code, there is time complexity, space complexity. So I'll come back to them one by one. So let's try to think about a algorithm design by looking at this example here. First example. So I have 1 2 3 4 5 and the left is 2. So it is a position, it is not the index will start from 0, but in this case the position is starting at 2, which is the second, and the right position is 4th. So 1 2 3 4. Yeah, and what I want is just reverse this linked list. Okay, yeah, now how can I do this? Let me think about a situation where I had like 1 2 3, and in that case I know how to reverse it. So 3 2 1, this is what I will get. So what if I just so let's say this was the list 1 2 3 4 and 5, and I break this list into so I will make head as a 2, and then I will have this link list 2, 3 and 4, and I will break this link here, which will point to none, null or none, right? And I will keep these nodes some pointers to them. So the original head and the breaking point of that, and this node and breaking point of that, that is this. And then I reverse this linked list with the basic logic of reversing, and then I will get the linked list as 4 3 2, and then I will connect this 1 with this 4, the original, or maybe wherever this had broken, from there to this 4, and from this 2, which will be pointing to null, to this this next part of the linked list. So I think that can be done, but there are like few pointers to keep in mind. So that's how I'm thinking right now. So let me take like 2 more minutes to think if there is some another way that I can do to reverse it in a little bit less messy way. Let me think. Mm, mm, because current solution is going to work, it will be a linear solution, and but the only thing is it will have like too many if else cases and too many pointers to handle. But okay, another way that I understand is, let's say I was given this linked list. Okay, this is another solution that I have come to understand. What I will do is I will make a clone of this linked list, and I will reverse that. So 5 4 3 2 1. Okay, and I will have this as a head, and now this has a head. So now I will start iterating over both. So I go from here to here, and if I found the left, so if current dot next is left position, right, then what I'm going to do is I will point this current to this node, and then I will go in this list, okay, iterating on both, no, on both. So basically I will point this here and this here. I will go straight in this direction until I get to the right, or current dot next equal to right. And once that is done, I will point from here to here and here to here back, and then I will return the original head. So this is like a linear solution, which writing this solution is going to be I would say easier than all the if else cases, and but this is going to use an extra memory of like O of n. In this case it will be a constant memory. So um which one I should go for? Which one I should go for? um I think I will go with the first approach. mm, 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 mm. So I want to write a function that is going to reverse a list, and it's gonna get head. Mm, mm. It's gonna get head, and it's going to return a reverse list. Right, but I think it should return the tail as well, right? So it's gonna return like something like new head, new tail. Okay, there is a lot of silence in here. Okay, okay, okay. How should I do it? So let's say if left equal to right, if the position is pointing to the same, then directly return head. This is one of the edge case, and there is one another edge case where like the head, we want the full list to be reversed, right? Or the starting position is 1. In that case the head is going to change. So that is one case. If left equal to 1, and pass. So this is what I was saying. There is another case where the right equal to, but we don't know end of the list, right? So yeah, this is one case. I can handle this by maybe having a dummy node head pointing to the current head. I can do that, right? I really don't want to code this thing, man. Okay, so how can I do this? How can I do this? Um, uh, so in real interview, I would use some pen and paper or or a whiteboard to just point out how the pointers are working, and then I would write this code. Right now I am not in the mood, so I'm gonna just see the solution. But I believe this should be a correct approach. But not, let's see what is the approach here. Iterative link reverse. What is this? What is this? So if m equal to n, this case I handle, then there was a dummy head case. Okay, so for I in range m minus 1, previous is equal to previous dot next. So m and n, yeah, okay, and then reverse equal to none, current equal to previous dot next, and then for I in range n minus m plus 1, reverse this much part, and then previous dot next is equal to current, previous dot next is equal to reverse. What is reverse? Reverse is none. Okay, so yeah, okay, I think this is good enough solution. I would have coded in a similar way, but not that much elegant. Why these people change? Okay, let me just change this. Yeah, so basically what is happening is, um, this is the base case. Okay, if left and right is equal, then we don't have to do anything because it's just one node, right? So we just return head. But in case it is not, then what we are doing is we it's a good idea to have a dummy node to avoid like multiple if else cases. That was one thing I was talking. Now this is another thing that, um, what we are doing is, uh, m is the start index, right? So we are just going to the position where, from where the reversing should start. Okay, the starting point of the reverse. So we reach that node. Okay, and then we start, from the next node we start reversing the linked list. So this is the code for reverse linked list. But normally here the condition is while current is not equal to null, but we don't have to do that here because we only have to reverse these many nodes in between. So here this is happening like we are taking the current and then we're pointing this to null, and then, um, this becomes this, and this is the 4 line logic for reverse. This you have to and know, just know, if you don't know, then you have to solve reverse linked list 1 before this question. And then what I was saying is this similar. So whatever the previous dot next is going to be current. So, um, this is the thing I was talking about, having to keep multiple pointers. But, uh, in my mind I was thinking that I should keep multiple pointers, but, in this code wise, we don't have to. We just need to remember that, yeah, this node dot next should point to the reversed list of current, and then this node, the last node, should point to the reverse. So that was pretty much the code, and this was to avoid any base cases. So, always, when we reverse the code, we had our dummy node. So dummy node dot next was our head all the time. So that's the answer. Yeah, so thank you so much for watching. I don't think you will gain anything from this, but yeah, bye.